attention as we start our tangent lines. Now, you know what a tangent line is. A tangent line is going to intersect the circle at how many places?
One.
At one point, and we call that the point of tangency. So in this example right here that I drew, will you let my friend in? What is my point of tangency? A. And that means my tangent line is AB. Well, there's something cool that happens. A line is tangent to a circle if and only if it is perpendicular to a radius drawn from the center to the point of tangency. Now, what does it mean to be perpendicular? If it's perpendicular, what's it meet at? A right angle, which is 90 degrees. So, just because something looks tangent does not guarantee it is. The only way to guarantee it is to either be told that this is a right angle or to use information to prove it is in fact a right angle. And that's actually the first thing that we're going to start off with number 1 and 2. It says determine if segment AB is tangent to circle P. Now, if segment AB is tangent, that would mean that this has to be a right angle. And so that would mean that we're looking at a right triangle. Think back to everything you've learned over the last few years. What is it that you use when you have a right triangle in all of the sides? Pythagorean theorem. Very good. So you're going to use the Pythagorean theorem to either prove or disprove, which means say yes, this is a tangent, or no, this is not. So I'm going to make us a note. When we see these directions, we're going to prove or disprove with the Pythagorean theorem. And we're going to write ourselves a note. What is the Pythagorean theorem again?
A squared plus B squared.
There we go. A squared plus B squared equals C squared. So what you have to do is you have to figure out where is supposed to be the right angle so that you can find your sides, your legs, and your hypotenuse. Okay? So now, in number 1, if this is your possible tangent, A is the point of tangency. That should be A. If it's really a tangent, it will be the 90-degree angle. Okay? So if A is supposed to be the 90-degree angle, which one of those sides would be your hypotenuse?
15.
Now, if this is your 90, you've got to go across to the 17. So you're going to set that up. A squared plus B squared, you're trying to figure out basically like a giant question mark. Is that really true? If that is a true statement, so if the left equals the right, then yes, that's a right triangle, which means that this is a tangent line. If the answer is no, then it's not a right angle, which means it is not a tangent. So I would type in the left side and the right side. So I've got 8 squared plus 15 squared, which gives me a total of 289. 17 squared gives me a total of 289. Is it true that 289 equals 289?
Oh, yeah.
Yeah. So that means that this really is a right angle. And so if this possible tangent AB meets at a 90-degree angle, then yes, it is a tangent. So if the Pythagorean theorem is true, then it really is a tangent line. Alright, so the tricky part about this, you're basically going to be using on today's lesson Pythagorean theorem the whole time. It gets a little tricky if maybe I don't tell you every single little measurement, only because of the fact that you're going to be in a hurry and you're going to assume that that one measurement is the whole side. Like for instance, when you look at this, you're going to be in such a hurry, you're going to say 11 and 14 and 5, and that's what you're going to use. But 5 is only talking about from B to the edge of the circle. You have to know all the way from B to P. So you're missing P to the edge of the circle, which is a radius. What is B or P to the edge of the circle equal to? Do you see any other radius? 11. Because 11 is the radius here, that means it's the same on any other radius in the entire circle. So, B to P is 5 plus 11, which is how much? 16. All right, now, your possible tangent is AB. So where should your possible right angle be? Right there at A. So if this is possibly my right angle, what is my hypotenuse? Talk to me. My hypotenuse would be my 16. So 11 squared plus 14 squared equals a possible 16 squared. Now, simplify each side. You're trying to figure out, is a giant question mark, are those two equal or not equal? So 11 squared plus 14 squared equals 317. 16 squared equals 256. Is it true that 317 equals 256? No. So since that's not true, that's not a right triangle. And if this is not a right triangle, that's not perpendicular, so no, segment AB is not tangent to circle P. So let's move on to the next set of directions. Every other question we're going to do today has the same set of directions. If segment JK is tangent to the circle, so I know for a fact it is. You know how I know it is? It told me. Then I need to find X. Well, since it tells me JK is tangent to the circle, that means the point of tangency has a right angle. So there is my right triangle. Alright, and I need to look at the measurements they gave me and make sure that's the whole side. So 7 is from L to J. From J to K is 19, and from K all the way back to L, that's X. So I have all three sides. Which of those sides is my hypotenuse? The X. That's the one you really got to make sure you get in the right spot, okay? Now, you might be saying, Ms. Slusher, can't I use cosine, sine, cosine, and tangent? Not this time, because you don't know an angle. Since all you know are side measurements, you have to use Pythagorean theorem to find. So, a leg is 7, a leg is 19, and our hypotenuse is our x squared. So, I did x squared, and then I just take these two and I go ahead and add them. Rather than simplifying and getting that 7 squared is 49, I just let my calculator handle all that for me. And I get 410. Now, that's not x, that's x squared. How do you unsquare x squared? Take the square root. All right. So let me take the square root of 410. Okay? Oh, 410 gives me back the square root of 410, so that means it's a decimal. Now, you have to hear me very carefully because I'm telling you, and you need to make sure that this is how you round. You're doing a measurement. If you go today and you look at the odometer on your car or truck or your parents' car or truck, it's going to, what do I call it, speedometer? That's what I said. Yeah, the odometer. Odometer? Whatever. All right. Then it's going to measure to the 10th of a mile. If I gave you a ruler and asked you to measure your pencil, you're going to measure it to the 10th of an inch. So when we do segments, I want you to do to the 10th place. So that's 1 decimal. What is a 4 going to do to that 2?
Leave it at 2.
Leave it at 2. So it's 20.2. And now, just for professional sake, it's not equal, it's approximate because I did have to round. So, x is approximately 20.2. Alright, so number 4. Okay? I need you to look at where is your tangent. Your tangent is J to K. Where is your point of tangent C? At J, that is where you are perpendicular. How do I know it's perpendicular? Because I was told it is tangent, and a line that is tangent to a circle is perpendicular to the radius at the point of tangency. Now, from J to K, that's X. From J to L, that's 11. What is 7 referring to? Is it the entire length from K to L? Nope, it's just K to the circle. So what are you supposed to do to find that entire length KL? What are you missing that you actually know? 11. This is 11. Because this is a radius from the center to the edge, that's the same as that one. So what is 11 plus 7 more? That would be 18. Which of those sides, x, 11, or 18, is your hypotenuse? Across from the 90 would be 18. So, a squared plus b squared equals c hypotenuse squared. Thanks, buddy. Now, I want x squared by itself. So I'm going to get rid of plus 11 by minus 11 squared. Those cancel out. X squared equals, now I type that in my calculator. I did 18 squared minus 11 squared. Let it do my work for me, and I get 203. How do I unsquare? Square root, okay? So, the square root of 203 is going to be a decimal, so let me use my approximate. I'm doing a length of a segment, so I've been told to measure to the hundredths place, or tenths place, sorry. What is a 4 going to do to a 2? Nothing. So it's approximately 14.2 is the length of that missing side. Alright, so we're going to look at the back. Okay? And so when I look at number 5, something kind of different than what's happened so far happens. Where is my right angle? It's at J, because that's the point of tangency. So J to L, which is a radius, is 10. J to K is 24. If you're talking, you need to stop unless you're talking to me. X is from K to the middle of this, to the edge of the circle here. What is the rest of the way to L? The radius, so that would be 10. Now, what is my hypotenuse? That's across from here. That would be this side right here, which is technically x plus 10 more, okay? Now, I'm going to show you something. If you are really great at quadratics, okay? And so you remember back to algebra where you had to solve by factoring, or you had to take the, use the quadratic formula, then you would do this. Now, I'm going to show you a shortcut after that, okay? Do not write what I'm about to write. Okay. So, this is a squared. This is b squared. Here's the tricky part. What is your c? It's x plus 10 more, and you would have to do x plus 10 squared, right? Now, do not write what I'm writing. I'm showing you one way if you are super proficient at doing your quadratic formula type stuff. All right. If I simplify this, I get 670, no wait, where's my paper? Yeah, I get 676, okay? But now let me come down here to the side. If I do x plus 10 squared, that means x plus 10 times x plus 10, right? What's x times x?
2x.
Nope, x squared, very good. What's x times 10?
That's what I meant.
I knew what you meant, 10x. And what's 10 times x? 10x, and what's 10 times 10?
100.
So when I simplify this, I get x squared plus 20x plus 100, right? Now, that's a quadratic equation. I've got to get everything on one side, so I would minus 676. And I would have x squared plus 20x minus 576. And I got a couple options right here. I could either factor and figure out what two numbers multiply to give me a negative 576 and add to give me 20. Or I could do the quadratic formula, which you might not even remember. Okay? Quadratic formula. What's quadratic formula? You don't know. Negative b plus or minus the square root of b squared minus 4ac over 2a. Now, what's my a? Or I guess I should say, what's my b?
It's a 10.
It's the 20. B squared minus 4ac over 2a. You would type that in, the plus and the minus, and your answer ends up being 16. Now, did you even remember how to do that? No. I didn't think you did. And most people didn't like that to begin with, so I'm going to throw that away. All right. I'm going to show you an alternate way to do this. You could do that, okay? What I'm about to show you, though, only works if you've only got x's on one side. Here's what I mean. You've only got x here. If you had an x here and an x here, it wouldn't work. I'm I'm going to name that side something totally different, okay? I'm going to call this side y. Now, what do I know y equals? Y equals x plus 10. But in the meantime, naming that y means it reduces what I'm looking at. So I've got 24 squared plus 10 squared equals y squared, which looks a whole lot better than that. So now, keep solving. What is 24 squared plus 10 squared? 676. Okay? How do you get y by itself? How do you unsquare it? You take the square root. What is the square root of 676? You got a calculator? I'll tell you. It's 26. Now, 26 is not x. 26 is y. 26 is the distance from here all the way to here. So if 26 equals x plus 10, how do you find what x is?
Subtract 10.
You subtract 10. And what does x equal?
16.
16. So if you did that, or you did it this way, you get the same answer. It's just that you probably didn't remember this just off the top of your head. Okay? Now, I do want to point out, the only reason I'm allowed to name this some other variable is because that was the only x on the side I was using. If I had an x somewhere else, I can't have x squared and a y squared when I'm doing Pythagorean theorem. I have to have the same variable. All right, so let's go on to our number 6. Okay? So I need to figure out where is my right angle supposed to be. My point is at my point of tangency. So j to k is the point of tangency happens to be j in every one of these. Okay, just to kind of keep it the same. Now, that means, what is my hypotenuse? Across from my 90 would be 25, okay? That's my hypotenuse. X is a leg. Is 11 the entire other leg? No, 11 is the radius. So if from L to J is 11, what else do you know about L to M? That's 11. So what is this side? 22. You add them together. So now you will do a squared plus b squared equals c squared. So I have x squared plus leg squared equals hypotenuse squared. So I'm trying to solve for x, so I'm going to get the 22 squared. I'm going to use my inverse and subtract it. Alright, so 25 squared minus 22 squared, x squared equals 141. How do I unsquare something? I'm going to take the square root. So the square root of 141, it's going to be a decimal. So let me take that equals to a approximate, because I'm about to have to round this thing. I'm going to round to the 10th place because we measure distances in the 10th place. So what is a 7 going to do to that 8? Make it a 9. So that x is approximately 11.9. Alright, so what I want you to do is I want you to practice number 7 all by yourself. 7 is very similar to the one that we just did. And I'm going to tell you what your answer should be, not so that you can steal my answer, but so that you'll know when you get it if you're right or not. So you do number 7. Alright, so I had you finish this out. Now, what is the one thing that you had to recognize and realize here? 3.5. Very good. 3.5 is from L to J, and because this is also a radius, the entire diameter was 7. So, where is your right angle? At your J. It's at your point of tangency. So, 7 squared plus 6.4 squared equaled x squared. And so my x squared equaled, I typed these in, and I had 7 squared plus 6.4 squared, which gave me exactly 89.96. And I took the square root of both of those and ended up with 9.5. Alright, so this next one, number 8, it gets a little different, and there's actually a couple of ways that you could work this one. So I want you to look right here. Alright. My point of tangency is again at J, because JK is my tangent line. I need you to be quiet. Alright? And And so I've got 7 as my side, 25 as my hypotenuse. Is x this entire side? No, it's just the halfway, the radius. So that means this is x. So actually together, what would x plus x be? It would be 2 x's. Now, you could absolutely solve it that way. But what you would have to do is realize that you would do 7 squared and 2x squared, which means 2x times 2x is 4x. So let me show you how I solve this on my scratch paper right here. You do not have to write this down. Okay? So, 7 squared plus 2x squared equals 25 squared. Now, 2x squared means 2x times 2x. And what is 2x times 2x? 4x squared. So you would have to make sure you realize that. That is the first mistake if you started doing it this way that I'm predicting that I'm looking at. Now, if I keep solving, I can minus 7 squared from both sides, and that gives me 4x squared plus equals 576. Now, can I take the square root yet? Not yet, because I want x squared by itself, so how do I get rid of times 4? I divide both sides by 4, and I originally had x squared equals 144, and I took the square root to give me x equals 12. If that way makes sense to you, you could absolutely do it that way. But there's a lot of people that are going to mess up in this step right here. They're not going to do 2x squared. They're going to put 2x squared instead of 4x squared, and they'll be totally wrong. So,
X squared and then divide it by 2. For me,
Eventually, yes.
using x squared gave me 24 and I divided it by 2.
There you go.
So I
So,
mean it as both 2 x's.
there you go. There you go. So you could totally work it that way. Now, the other option here is to just call this side. Because these x's are on the same side, okay, you're listening, I can name this a totally different letter, like I did before. I'm going to name this y. And now, what is y the same as? What's it representing? It's representing 2x. So I would do 7 squared plus y squared equals 25 squared. And then when I subtract 7 squared, y squared equaled 576. And when I took the square root, my y equaled 24. So this entire thing is 24. And 24 is 2 x's. So basically, what do I have to do with 24 to get just one of my x's? I have to split it in half. And so 24 split into 2 equal x's is 12. So whether you renamed it because the x's were in the same side of the triangle, or you just did the math, the algebra, you're going to get the same answer. Now, those of you that are really good at algebra, probably going to want to do this way, and I'm totally fine with that. Those of you that aren't so good or aren't so confident with your algebra, because these are on the same side, you can rename it and then just figure it out as like a sub-step. Now, I'm about to show you one where you can't rename it, okay? And you're going to be forced to do that algebra. So, from J to K, that is tangent, so there is my right angle. From J to K is 20. From J to L is x. From K to the circle is 10. What is the rest of the way from the circle to L? It's also your x. It looks like it's split in half, and it might be, but I don't know that. Okay? Now, this side right here, that's x plus 10. And you might be thinking, Miss Slusher, can't we just name that y? No, because this would be x squared, and that would be y squared, and you can't have 2 different variables. So you're forced this time to do x squared plus 20 squared equals x plus 10 squared. So you're forced into that algebra quadratic situation. Now, I'm going to come to the side and simplify this. So x plus 10 times x plus 10. All right? x times x is x squared, x times 10 is 10x. Distribute the 10, 10 times x is 10x, and 10 times 10 is 100. So that when you simplify it, that would be x squared plus 20x plus 100. Okay, so let me go simplify this. So I've got x squared plus, because I'm using regular numbers over here, I'm just going to go ahead and turn that 20 squared into a regular number. What's 20 times 20? Talk to me. 400. Now, you're already looking at this panicking and you're thinking, that's it, I'm going to have to do quadratic formula. Well, let's see what happens. Try to get your x squareds on the same side. So, let's move this x squared over. What's the inverse of positive x squared? Negative x squared, okay? So before we start to panic, let's work it out. What's x squared minus x squared? Zeroes out. What's this x squared minus this, or x squared? Zeroes out. Hallelujah, what happened? Your x squareds went away and it's no longer quadratic. And so you say, all right, I just need to get my x's on one side, my numbers on the other. So let me minus this 100. That's going to zero out, leave me with 20x equals, what is 400 minus 100? 300. How do I undo times 20? Divide by 20. Now what is 300 divided by 20? 15. So that's my x. If I asked you, let's just say I had asked you for the measurement of LK, how would you find the measurement of LK? From L to K, that would be 15 plus, you plug x in. 15 plus 20 would give us 25 total. Now that's just what I would do if I asked you. I asked you for x. Okay? The reason I could not simply rename this and let it be y is because I can't have x squared plus 20 squared equals y squared. I can't have two different variables. I was forced to use my quadratic stuff. So, in summary, if I ask you to determine if a segment is tangent, what did you prove it using? You plugged everything into the Pythagorean theorem. If the Pythagorean theorem is true, then yes, it is tangent. If it's not a true statement, then no, it's not. And then what did you use every time to figure out a missing value here? You used Pythagorean theorem every time for these basic tangent lines.